Okay, so I want to do number 32 and 18.1, which says I want to make this line integral positive, right? And the line integral I'm trying to execute is integrating the vector field that's given by AYI plus CK, where C is the, so not the same C, but where the curve I'm talking about is the unit circle in the XY plane oriented counterclockwise. Right? So I have thus far called out of this picture. There is a unit circle in the XY plane, which looks like this. That is the shittiest unit circle.
Great axes though.
I know, the axes went really well, and then the rest of it just fell apart. Whatever. Okay, so I have a unit circle in the XY plane oriented counterclockwise, right? And I need to make specifications on A and C, right? So that this vector field helps me out around this circle. You guys see that? Okay. So, yeah, I'm kind of noticing like f of x and y is AY comma 0 comma C, right? Does it matter whether that vector field's arrows tend to point up or down?
Not as long as it's specifically on this plane.
Yeah, not really at all, right? You guys see that?
It's always
Like, I don't care where those things point. So I think I'm going to end up with C doesn't matter at all,
Yep. I'll have all real numbers.
right? And then I need AY to help me out going around this curve, right?
Yep.
You guys see that? But that's in the X component, right?
yeah.
Okay, so could maybe reason this out, or we could think about how we would go about executing this, right? You guys see this?
Yep.
So how would you parameterize the unit circle there? You do x is cosine t, y is sine t, right? And your t's would sit between 0 is less than t is less than 2 pi. Cool. Pretty good. Okay, so I would do the integral from 0 to 2 pi, right? Of something dotted with, okay, so I need the derivative of the parameterization. Oh, wait, what's C?
Z is just 0, isn't it?
Yeah, I want it to be in the xy plane, right? So specifically, the z needs to be 0 all the time. Okay, so the derivative of my parameterization should go here. So that's going to end in a 0. And you get negative sine t cos t. You guys cool with that?
Yep.
Okay, and then this middle guy, that should be what?
F of x.
F of r of t, right? So I should get a times sine of t, right? Comma 0, comma c. And now when I dot product, yeah, the c drops out, right? But so does the cosine t. So you get the integral from 0 to 2 pi of negative a is a constant, right? And then you got a sine squared t dt.
Just 0.
Careful.
Well, I mean the signs. Oh, it doesn't.
So the fact that it's sine squared means that that doesn't zero out, right?
Okay, I apologize.
So you need to use the half angle identity first, and then maybe you'll get something to zero out.
Yeah, okay.
Okay, so hit this thing with a half angle, and you get minus a, the integral from 0 to 2 pi. Oh, maybe minus a over 2, right?
Yeah.
And a
1
1 minus cosine 2t dt. Yeah, the half angle identities both have cosine in them.
Just one is 1 plus, the other is 1 minus.
Yeah, the cosine one's 1 plus cosine 2 theta over 2, and the sine one is 1 minus. Okay, so you get this, and then this cosine 2t part, then,
Oh, yeah, this is the one that zeroes itself out.
yeah, this thing zeros because it's a trig function over
It's
2
two
grid.
periods.
Okay, so I got minus a over 2, the integral from 0 to 2 pi of 1 dt. And so you get out of this
Negative a pi.
negative a pi. So if this thing's going to be positive, what do I need for a?
Be negative.
So I need this to be bigger than 0. So a should be less than 0. Because you apply the decreasing function, right? Flip the sign and divide by pi.
Where do we get this apply increasing or decreasing function thing?
Because we lied to you a long time ago.
We
So-
talked about it once for like a second.
Yeah, so there's this thing, and you have x squared is less than 1 or something, right? You guys just very happily will square root both sides and say, okay, so x is smaller than 1. Right? Yeah, this actually isn't even true, right?
Well, the
What do you need
absolute
to
value
do?
of it.
Yeah, the absolute value of x is smaller than 1. So 1, I have to keep track of the fact that the square root of x squared isn't actually x. But 2, why should that be less than instead of greater than? Like with those things, like in algebra 1, the only thing we told you is it's like equations, but if you divide or multiply by a negative number, you have to flip the sign. How do you know square rooting isn't like a negative number?
Is increasing?
Yeah, because it's an increasing function. You
Oh,
guys see that? So when you apply an increasing function to both sides, it preserves equality. When you apply a decreasing function to both sides, it switches equality.
so the absolute value is basically saying, hey, sometimes it's an increasing function, sometimes it's a decreasing function, sort of.
That's actually just keeping track of the fact that the square root of x squared isn't x.
Oh, okay.
Maybe a better example, less confusing, would be if it is x cubed is smaller than 1. Right? Somehow you can cube root both sides of this equation, and the inequality is preserved. Right?
Okay.
But that's only because cube rooting is an increasing function the whole way. Okay, cool. So what did we get in the end for this thing? We got a is smaller than 0. What about c?
It could be any real number.
Yeah, c can be anything. So you can just circle a has to be smaller than 0. You guys kind of see that? You could, of course, have reasoned that out by thinking like, okay, I'm going to just draw some vectors over here. Like assuming maybe a is 1 or something. I could draw a vector field and see that it's not helping. But of course, that's going to be a little tough to eyeball where that flips, right? You're going to have to like play this like, oh, what if I try 1? What if I try 0? What if I try... Wait, what if you try 0? So what's your vector field look like if you plug 0 in? You get 0, 0, C, right? So you just have a k component, which means that your arrows for your vector field are pointing straight up or straight down, right? They're going like this.
Which is nothing in the explanation.
Yeah, which is neither helpful nor unhelpful, right? It's just passing through. Who cares?
Speaking of which, the f vector that you put f of x and y, it's not of x and y, it's just the f vector.
No,
Or it's f, x, y, and z. because-
it's f of x, y, and z, because it's 3-dimensional,
Yeah,
not 2.
I just wanted to know that because you
Yeah.
doing that at the beginning.
I think when we were eyeballing it though, that we had it in a 2D plane, and we saw the unit circle, we were thinking symmetry. And we were wondering that why wouldn't that be 0 because A and Y.
Yeah, so it's because the y got switched into that x slot.
Yeah, but still wouldn't it be symmetrical? Because if you think about the,
Well, so are all the vectors in the field going to point in the same direction? Would that would make it?
No, so these won't all point in the same direction. As you change from, let's think about it. So this is the y-axis, right?
We're looking straight down right now.
This is the, so I have a y-axis and an x-axis, right? And I'm thinking about the vector field f is given by
Y0.
like a, y, and 0, right? So let me just assume a is 1, just to make my life a little easier. Okay, so when the y's are positive, right, so up here, which direction does this thing tend to point in?
Right.
It tends to point to the right.
Yeah.
Like, disregarding magnitude, it tends to point to the right. When y is negative, this thing tends to point to the
Left.
left. You guys see this? So if I'm thinking about traversing in a circle here, right, like going around the unit circle, up top here, those are fighting me, and then down below, they're still fighting me, right? And that's because the x and the y interchanged roles. If they hadn't interchanged roles, you'd be probably right.
But if
Yes,
that was
yeah.
negative y, comma 0, then it would be helping you the entire time.
Yeah, so if I flip the sign on this, right, which is really what I needed to do, it'll help you the whole way around. Cool, cool? Oh, please note, down in here, it's actually 0, right? Which is neither helping nor hindering.